use the elimination method to solve these systems of linear equations. So the first equations, we have fractions. So this is x minus 1 over 2 plus y plus 2 over 3. Whenever I see a fraction, I want to get rid of the denominator immediately. So to get rid of the denominator, one of the ways to do it is you multiply both sides by 6. 6 is big enough to get rid of the 2 and the 3. And then for the second equation, there is no denominator. We leave it as it is. So back to this color. So what do we have after we multiply by 6? So we have 6 divided by 2 is 3. Then we have 3 times x minus 1 and then plus 2 times y plus 2 equals to 24. And then the second equation is x minus 2y equals to 5. Distribution, so the next step, we have 3x minus 3 plus 2y plus 4 equals to 24. And then x minus 2y equals to 5. And then for the first equation, we can rewrite that as 3x plus 2y 3x plus 2y, and then 4 minus 3 is 1, and then 24 minus 1 is 23, so this is a 23, and then this is x minus 2y equals to 5. Now, do you see that this is a 2y and minus 2y, so that means once I add them, the y's will be gone. So once I add them like that, the y will be gone. So 3 plus 1 is equals to 4. 2 plus negative 2, which is 2 minus 2 equals to 0. And then 23 plus 5 is equals to 28. So that is equals to 28. And then what is that equal to? X is equals to 28 divided by 4. So x is equals to 7. And then when x is equals to 7, you plug it into either one of the equation. I prefer to pick the second one. So we have 7 minus 2y equals to 5, and then negative 2y is equals to 5 minus 7, which is equals to negative 2, and then y is equals to 1. So y is equals to 1, x is equals to 7. What does that mean? That means this point x comma y is equals to 7 comma 1. So when you sketch the graph of these two equations, you can sketch the graph of these two equations. Using decimals, you see two lines, and then those two lines, I don't care what the line looks like, increasing, decreasing, I don't really care. All I need to know is those two lines, they intersect at 7 comma 1. So 7 comma 1 is the point where they intersect. All right, so that is the first system. Let's move on to the second system. The second system, you have 7x plus 8y equals to 6, and then negative 14x minus 16y equals to negative 12. So you can't just add or subtract to eliminate one of the variable. So the first thing that I would like to do is I would like to get a 14x in the first equation. So let me change to a different color. Actually, I want to use red. So we multiply both sides by 2. So multiply this side by 2 and then multiply this side by 2. And then the system becomes 14x plus 2 times 8 is 16. 16y equals to 12. And then this is negative 14x minus 16y. I forgot a y here. And then equals to negative 12. And then what happened when you add them? So when you add them, here is what you are going to get. Do we agree that once you add them, both variables will be gone simultaneously? So this one, we will actually have a 0 equals to 0, but 0 itself is equals to 0. What does that mean? That means this system has many solutions. And then when a system has many solutions, I do not want you to just stop right there. I want you to generalize the solution for me. So here is what I am going to do. I am going to let x equals to a, and then I will solve for y. And then in the first equation, 7x plus ay equals to 6. You can pick either equation. Since the first equation has smaller numbers, I will just put that in the first equation. Then we have 7a instead of x, and then plus 8y equals to 6, and then tell me what y equals to. So we have 8y equals to 6 minus 7a divide both sides by 8, you have 6 minus 7a equal divided by 8. So they both share the 8. Then you have 6 divided by 8 minus 7 divided by 8. And then letter A. So at the end of the day, what do we have? We have y equals to, that is a 3 over 4, divide top and bottom by 2. And then minus 7 over 8. So that is the general answers for y. So that means the x comma y, the intersection, is equals to, when x is equals to a, y is equals to 3 over 4 minus 7 over 8. So what that means is this is the intersection. So when you find a solution for the system, you have to give me an x value. So whatever x equals to, so let's say x equals to 0. So let's say here, x is equals to 0. And then you plug in 0 there to find a. So in this system, when x is equals to 0, y is equals to 3 over 4. When x is equals to 1, y is equals to 3 over 4 minus 7 over 8. Then you have to get a common denominator. So that is how you generalize the answer when the system has many solutions. All right. So moving on to the last system. The last system, I want to do some decimals. So what happened when you see decimals? Let's pick a different color. How about we pick a pink? So the last system, I have 0.5x minus 0.3y equals to 6.5, and then 0.7x plus 0.2y equals to 6.0. So that one, whenever I see decimals like this, I want to make it a whole. I don't want to work with decimals like that. So to get out of the decimals, I am going to multiply both sides by 10. So to give myself some space, I'm going to move the equations a little bit and then switch to a different color. So multiply the left hand side by 10, the right hand side by 10. Second equation, multiply the left side by 10, multiply the right side by 10. So that is the way to get out of the decimals. Just like fractions, whenever I see fractions, I want to get rid of the denominators. Okay, back to our main system. So we have 5, so it's an integer, minus 3, integer, and then equals to 65. They are all integers. And then 7x plus 2y equals to 6. So no more decimals. Can we add and subtract now? That now is not a good time, because even though you add and subtract, we cannot get rid of any variable. So how about this? Let's get a 6y right here. So in order to get a 6y, I'm going to move my equation to give myself some space. I have to multiply the first equation by 2, the second equation by 3. So let's switch to a different color. So multiply this by 2, and then multiply the next one by 3. So multiply the next one by 3. Let's take multiply the next one by 3. And then what do we get? We have 10x minus 6y equals to 65 times 2 is 130, and then 21x, I clearly forgot an x right there, and then plus 6y equals to 18. So now I can just add the two equations to get rid of the y, right? So I'm going to add the two equations to get rid of the y, and then what do I get? 10 plus 21, that is 31x. Y is gone, and then 130 plus 18, that is equals to 310. Did I make a mistake right here? Multiply by 3. I make a mistake when I was writing my notes. Okay. Because I thought that is 180. So let me go ahead and then get rid of that. Okay, let me make sure that I didn't copy the problem wrong. 0.5x minus 0.3y 6.5, 0.7x 0.2y 6 multiplied by 10, 65. Ha! 65. 65, 6 times 2. That 6.0 times 10. That is a 60, not 6, 60. Huh. This is a 180. My notes is right, but I just forgot a 0. Okay, so this is a 310. Okay, numbers is nice. So at the end of the day, then x is equals to 10. So when x is equals to 10, which one should I choose? Let's put it to the first one. 10 times 10 minus 6y equals to 130. So you have 100 minus 6y equals to 130. Subtract both sides by 100, you will have 30, and then y is equals to negative 5. So y is equals to negative 5, and then this is my other solution. So you have an order pair x comma y, that is 10 comma negative 5. So what does that mean? You sketch the graph of these two equations. You have two straight lines, and then 10 comma negative 5 is the point where the two straight lines intersect. I don't care about the slope. Increasing, decreasing, I don't really care. You have two lines on the xy plane, and then 10 comma negative 5 is the coordinate where they intersect. Alright, so this is the last system in this video. If you like the way I teach elimination method, give this video a thumbs up, give my channel a subscribe. Trust me, it is worthwhile coming back to visit for more contents. As always, I will meet you all in the next video. Signing out.